Good morning. My name is BP Tiwari, and in the current presentation I will give you a holistic overview of WiMAX technology. We will cover drivers of mobile broadband, and then we will introduce WiMAX as a technology. We will also cover performance of WiMAX as a technology and also see an outer level of comparison with competing technologies like 3G uh, and and other technologies. And then we will briefly see WiMAX ecosystems, move to devices, and then touch base upon commercial networks. We are on slide number 3, and in this particular slide I'm highlighting the findings of Cisco VNI forum, and what Cisco has predicted that there are two major components that will drive adoption of mobile broadband in next 5 to 7 years, and there are two key drivers for a mobile broadband. One of them is video. Cisco has predicted that by 2013, 64% of the world's mobile traffic would be video, and that's a big number. And Cisco has also predicted that the advanced devices which are higher than 3G, like laptops, internet-centric devices like MIDs, notebooks, and netbooks, and laptops, will actually drive 80% of the traffic by 2013. And I wanted to also present here an understanding to my audience that a laptop or internet-centric device has much higher requirement of data than in non-internet-centric devices. So you can see in the left-hand side of the picture that 450 normal phones or a 450 voice phone generates similar amount of data that one internet-centric device actually requires. And here I would also like to highlight one of the findings from Cisco VNI research is today the amount of data traffic, average user data traffic for a laptop or internet-centric device stands at 3.1 gigabits per second, and which will grow to 25 gigs by 2015. And 80% of this traffic is coming from devices which are portable 3G and above, or residential 4G. So the two key findings from the last two slides are video is the real driver of data, which will move adoption of mobile broadband, and also the new advanced devices are actually driving the adoption of mobile broadband. Now the reason I'm presenting the real drivers is to actually lay foundation for a technology which is affordable, which has higher spectral efficiency, and which has a flat IP architecture, so that we can actually deliver much higher user experience and demand of future. Now mobile WiMAX is a technology which was created to enable internet on the go, and the real promise was to have anywhere, anytime, any device, any content connectivity. One of the things that is unique to mobile WiMAX is their mobility, personalization, and predominantly broadband delivery. So let me go deep here. When we say predominantly broadband, so mobile broadband or mobile WiMAX is based on TDD technology, which is essentially more suited for broadband based application, and it also has an mobility support. So a WiMAX release 1.0 network can support mobility up to 120 kilometer and a grateful degradation above than 120. And there is also something which is key to highlight, is there is a more open approach in this technology. So it actually leverages the full IP infrastructure that an operator has on an IP centric infrastructure, and also provides opportunity for new business models. Now there are key elements of WiMAX, and three of them is the most important one, and one of them is the OFDMA, which is also the basis of all fourth generation technologies. IMT Advanced has adopted OFDMA, as a baseline technology. And WiMAX also has MIMO. This is an advanced antenna technology which helps in delivering higher speeds and also combat multipath and improves quality in the network. And we also have something we call as an all IP architecture support in WiMAX. So as the world is moving towards an IP architecture, so WiMAX has adopted an all IP architecture, much flatter architecture, supports quite a good amount of quality of services and has wider channel bandwidth and has identified new spectrum worldwide. Now there are a lot of challenges which were actually thought of before defining the stand for mobile broadband, and the challenges are presented in the left side of the presentation, and we have also presented the approach what WiMAX has taken to solve those challenges. Now let's take the user experience first. So talk about the user experience. So now we have 3G networks which are HSPA and EVDO, and in comparison to these networks, WiMAX has a much higher quality of services. So if you have a WiMAX network, you on air you can define 4 to 5 classes of services which can essentially cater all kind of services for enterprise, for retail, for video, for voice, and it also has a flatter IP architecture. So the all IP based quality of services like cost of services and DSCP bit marking can be applied on WiMAX. Now let's talk quickly the RF part of the WiMAX. So one of the biggest challenge as you go on higher in frequencies to combat the multipath, and OFDMA is one of such methods which actually helps to combat multipath in a very efficient way. So OFDMA is introduced in WiMAX, and then there are much simpler deployment strategies in WiMAX like reuse one with partial uses of subchannels, and we will talk about these concepts in the next presentation, where we will go deep more in PHY structure of WiMAX. So the key message from here is WiMAX supports an OFDMA, has a MIMO based advanced antenna technologies to improve spectral efficiency and also have a quality of services. Now we are on slide number 7, and in this particular slide you can see the evolution of WiMAX as a standard. Now the standards that we will talk about today is 802.16e mobility, which was ratified in 2005. There are further improvements to these standards in 2009 and 2000 and a multi-hop relay. So IEEE has defined standards, and this is called 802.16 family, and there were revisions on the fixed standard to make it mobile, and more advanced features were also introduced in 2009. Now IEEE is also working to define the next version of the WiMAX standards, which is also called 802.16m, and we hope the ratification or standards to be over by 2010 second half.